welcome to this video. And in this video series, we're going to be talking about equations of straight lines. So these are different forms of writing equations of straight lines. So you're going to have one equation, like let's say y is equal to 3x plus 5. This one equation of a straight line. And you can write this in different forms, okay? So we're going to be learning all those different forms of equations of straight lines actually in this video series. Not entirely in this video, but this is going to be a video series consisting of each of them, okay? Today, we're going to talk about slope-intercept form, okay? An equation of horizontal and vertical lines. Though I have written it at last, but I'm going to talk about this at first, okay? I'm going to talk about this first, and then slope-intercept form. Okay, so we're going to talk about equation of horizontal and vertical lines, and the slope-intercept form of an equation of a straight line. And this is the most important and most used one also. Okay, so let's move on. But before talking about the equation of straight lines, you need to be familiar with something, and that is slope or gradient. It's also called the gradient of a line. Okay, so if you already are familiar with this, then you can skip through the video. You can skip a little. But if you're not, then stay there. What is the slope or gradient of a straight line? Let's suppose we have a straight line like this on a xy plane, Cartesian plane, whatever you want to call it. Okay, so this is our xy plane, and we have this line, and the slope of this line would be, what does slope mean? First of all, then let me tell you, slope is nothing but the rate of change. Rate of change. This is what slope is. The rate of change of a line is slope, meaning one unit of change in x causes how much change in y. Okay. So how do you compute this? Obviously, what you do, you divide them. Okay, because for change in x, let's do a change as delta. Okay, delta x. Okay, for this much change in x, our change in y will be, let's say, this much. Okay, so let's suppose that these two denote quantities. So these are change in x, these are change in y. So for this much change in x, this much is the change in y. So you're going to find out what is for 1 unit of change, or one little change. If you will make 1 unit of change in x, how much change will be in y? And that is pretty simple. This will be delta y over delta x, meaning change in y divided by change in x. And this is the rate of change, and this is what we call as slope. So this is nothing but this is what the slope is. This is the rate of change, how fast the line is changing. How fast the line is growing, or changing, increasing or decreasing. Because in this case, it's a decreasing line, it's negative slope. How do you know it's a negative slope? Because if you move, let's say this is x. If you move a little from there to this, let's suppose this is x plus h, because something is added to that. Okay, so this is x. If you increase that a little or move forward, then actually this gets decreased. Okay, y was first. Okay, y was first at this. Now, as we have moved ahead, as we have incremented x, you can see that y has gone up here, which is decreased. Okay, as there is decrease in y, we call it decreasing, negative slope. Okay, it's a negative slope. Okay, so we call it a negative slope. So this has a negative slope. In other words, the line is, as we move forward, this decreases. Okay, so if the line is like this, okay, tilted towards the right, then you can say that this has a positive slope. Okay, so it has positive slope. If we have another line, let's say, like this, it has negative slope. Negative slope. Okay, so these are what slopes are. Okay, and you can also think of slopes in terms of angles. Okay, because they depend on inclination. How much, at what angle there are, at different angles, slopes differ. Okay, so you can also think of them in terms of angles. So let's say the angle is theta here, theta, and slope is what? Just I told you, change in y divided by change in x. So, or rise over run. You can also term it as rise over run. So actually, this is our rise, this is our run. Why this is the rise, why this is the run? Let's say this is the initial point, and we went from this to here, which is the run, and from here to there, this is the rise. So from this initial point, we went there, which is the point has changed. The point has moved. Okay, and if you compute the change in y and change in x, divide them, in other words, rise over run, and this the rise, this the run, you're gonna have the slope. Or if you want to think of them in terms of angles, then there's nothing but this is opposite to the angle, and this is the adjacent. So use SOHCAHTOA, which is tangent theta. Okay, so m is nothing but your tangent theta, meaning slope is not, you do not slope by m. Be careful, it's not s. Okay, why do you do that? I also don't know, but we do not in by m. Okay, so m is tangent theta, slope is tangent theta. Okay, so this was a little lengthy, let's move forward. In summary, I can say that slope is change in y divided by change in x. If you want to make notes, do make the notes. Okay, let's don't write m here. Okay, so let's just write in short. M has tangent theta also. These are same thing. If you write this or write this, compute from this or compute from the angle, you're gonna get the same thing. Okay, if you a little extend this thing, then this is y2 minus y1 divided by x2 minus x1, meaning change in y divided by change in x. This is what slope is, and now we're done with slope. Okay, so please, know them down if you want to know them. Let's move forward now. Excuse me. Okay, so now we're ready to jump into equations of straight lines. So now let's talk about horizontal. Okay, this is not okay. Horizontal, and vertical lines. The equations of horizontal and vertical lines. So first of all, what is the horizontal and vertical lines? So you already know what the horizontal and vertical lines are. Now we're going to talk about the equations of those lines. So a horizontal line will be a line like this, parallel to the x-axis. Okay, so let's draw this on the xy plane. This is a horizontal line because it is parallel to the x-axis. Okay, so if you have a line which is parallel to the x-axis, it's termed as horizontal line, and the equation will be what here? The equation will be y is equal to something. Let's suppose that something is b. Okay, it's a constant. Why will be y is equal to a constant? Because you can see that whatever change you do on x, okay, for example, if you pick up this point, let's say this is 1. If you go to 2, if you move to 3, or even in the negative direction, you can see the y doesn't change. It's -1, -2. For all the x's, the y is constant. Y is this, the y is this constant, whatever that you have. Okay, let's suppose this is 3. So here, it is the graph of the straight line y is equal to 3. Okay, if you suppose if this is the 3, okay, if this is 3, then this is the graph of the straight line y is equal to 3, because you can see y doesn't change wherever you move on x. Okay, so we just say it's a constant, y is equal to 3. Meaning at whatever value of x, you're gonna have y the same or constant. You can also think of this in terms of functions also. So this will be f of x is equal to 3. So whatever value you plug in into this function, x denotes for the parameter, the input. Okay, so whatever value that you plug into this function, the output doesn't change. It's a constant 3. Okay, so this will be the equation of a horizontal line, and the equation of a horizontal line is y is equal to a constant. The constant in this case was 3, so it's y is equal to b if you have a horizontal line. Okay, so it's parallel to the x-axis, it's gonna be y is equal to b. Remember that. Okay, if it is parallel to the x-axis. So for horizontal line, we have talked what the equation will be for horizontal line. For horizontal lines, the equation will be y is equal to b. This is it. For a vertical line, for vertical lines, the equation will be, some of you might have got it already. If you haven't, pause the video and try to get your head around it, and maybe you could find it just on your own without maybe watching this further. Okay, the marker doesn't work. Here. Okay, so let's draw a vertical line now. This is a vertical line on the xy plane. This is our xy plane. Actually, the line is bigger than the xy plane. Okay, so this is a vertical line, and as you can see, at any value of y, the x doesn't change in this case. So what is constant here? It is the x value. I mean, at what? On the x-axis it is. So this is nothing but x is equal to something else, a constant. So let's call that constant a. Okay. So I have denoted the constant for x a and the constant for y b here. Okay. So at the x-axis, there is a constant number which is a. So the equation will be x is equal to a. For a vertical line, the equation is x is equal to a because it is parallel to the y-axis and it is a constant. Okay, so at x, let's suppose this is at 4, then the equation of this will be x is equal to 4. So this is for vertical lines. So for vertical lines, it will be x is equal to a. So this was for vertical and horizontal lines. Now I'm thinking of talking about the next thing, which was the first form of equation of straight lines, which was slope intercept form. Okay, but this video went too lengthy, so I'm gonna do that in another video. Or in the next video, we're gonna talk about the slope intercept form of equations of straight lines. Okay, so I say goodbye for now.